All right, so let's jump into the scatter plot now. So we looked at this one before, and it showed basically explanatory and response variables. And you should recognize that we use, just like we use throughout mathematics, we use the horizontal and vertical axis, also known as the x and y axis. At almost all times, when we are using this horizontal axis, we are measuring the independent or explanatory variable. Whereas with the y-axis, we're really measuring the dependent and response variable. We'd like to try and set that up. So whenever you have this equation, so I've got something like the mean score depends on how many people were taking that score. So I end up with here, let's say the mean score is equal to some sort of relationship with how many people take the SAT. So the mean equals some relationship with how many people take that. Again, normally we're used to seeing this quite often. We say this is y equals mx. And I'll talk about why I'm picking that one in just a second. But here's the scatter plot. And we talked about it before. We're just plotting all those coordinates. So for example, here is a coordinate, and I would think of it just like I would in any other setting. Like this is about 15, 500. So that means 15% of the people took this test in this state, and their mean score was 500. So if you notice, I'm taking those ideas and just simply putting them into, here's the mean, comma, the percent to take, comma, the mean. Just like I would with an x and y variable. All right, and you could look at all of these and put it. Now, when we're taking a look at this scatter plot, we're looking for patterns. We're looking for a general form and direction. And I think this one in particular kind of stands out as being, some people would say this kind of looks like it is following this straight line. All right, you might argue that it's not perfect. And I would agree with that. Some people would say it's not a perfect straight line. I, in fact, think that it maybe looks like it's slightly curved to the right as we're going through here. All right. Again, statistics is messy business, so we're talking about the shape of that. I would say that the direction is overall, it's pretty obvious that this thing is declining. If we think back to what we were talking about before with slope, I would say that if I'm looking at this thing, it definitely has a negative slope if I agree that it's defined by this straight line. All right, but that's what we're going to be getting into when we're talking about this correlation, is being able to now numerically graph it, to talk about how strong this graph is, or how closely following this pattern it is. It's not perfect. We have some outliers. In fact, the one that I outlined before, this guy really seems like an outlier of either of these two shapes that I generically put in here. He's way down here. The book points out that, and you should notice this as well, that this kind of follows two clusters, really. So let me grab this and erase it and get rid of this line for a second. Just move our line out of the way. It really seems to have two distinct clusters or groups. And again, this is just kind of guesswork as to where. Like, here is one cluster of information. And here's another cluster, and I'm just grouping these together. Like, you have two solid clusters. Notice that they both have a bunch of states. We have a bunch of states where a lot of people took it, and we have a lot of states that were in this range of 60 to 80% where they didn't all take it. There's no real clear pattern. We have states where a lot of people took it and we scored well, or no, a few people took it and scored well, and states where a few people took it and scored kind of average. We do notice that in states where more people have taken the SAT, it kind of varies as well. I've got some where they scored kind of in the middle. I've got, the same area where I've got two different responses for the same thing. So there's not a lot of conclusions I should necessarily draw from this. The one that I'm kind of noticing is that when you have all of your high school students taking the SAT, like you do at the states over here on the right, you're going to get a lot of different scores because not everyone is good at math. The states where not a lot of people took it, my conclusion, I guess, when I'm looking at this is, are these just the good students taking the SAT? There are some states where it's common for the colleges to do SATs. That's usually on the East Coast, on both coasts. And the ACT is more common for the Midwest. Is there more people, or only the people that are taking the SAT in some of these states? So this would be like Midwest states where most people take the ACT. Does this mean that only the students who are, going to maybe some of the more prestigious schools, you think like your Stanfords and your Yales and your Harvards, those are all coastal schools, those Ivy League schools. So they're taking the SAT to get into those schools. I don't know. I don't know if that's a good conclusion or not. But overall, I can see this correlation that's happening here. So keep in mind, whenever you're looking at this, we want to talk about the correlation. We want to be able to describe this correlation. I would say it's relatively linear with a negative slope. And later we are going to look at how to do something called a regression in order to find a mathematical formula to describe the data that we have here. So keep in mind, we want to look for patterns. We want to look for things that are outliers from that pattern. We want to look for the form, the direction, the strength of that data. So this is a moderately strong graph. Now I'll jump down to another one. So here is a correlation, and I think you would probably agree that this one has, again, a linear appearance. It looks like it's this kind of straight line. There aren't as many really oddball outliers, maybe a couple over here, but this one has a positive correlation. When we're talking about it, they tend to go up in value. And here we're talking about boats registered in Florida, and Florida manatees killed by boats. So it looks like the more boats that we have registered, the more manatees end up doing that. That makes the boats the explanatory variable, also known as the dependent variable, and this the response. All right. The fact that more manatees were killed was a response to the explanation of, well, there were more boats registered. So that might be one way to look at it. Again, strong linear correlation in a positive direction. Let's take a look at another set of data plots, some that have different types of correlations. So here, and we'll talk about giving these things values a little bit later, but hopefully you'll recognize them. Here I have some correlations that really don't fit. I always like the ones that are zero. You could draw a line right through here and have half of it above and half below. You could have a line going this way. I don't really know what direction to draw a line through this data. It really has no correlation. It's just completely scattered. When I look at this one, it is pretty scattered, but I think most people would agree they start to see some downward trend going in here. Same thing here. They start to see more of a positive trend where things are rising. Here you start to see stronger until you get to the point where you have a really strong correlation when we're taking a look at it. Now the numbers here, this correlation R, we're going to be talking about that as being just like the slope. And I didn't do a good job of drawing these, but a positive 0.5, that slope is like when we graphed things in algebra, if I had y equals 1/2 or 0.5x, it meant it went up 1 and over 2. So we would count up 1 and over 2, and there's a point, and up 1 and over 2, and there's a point. And so we had kind of a flatter line, but it was positive. When you had a slope like y equals 1x, it meant you went up 1 and over 1. So that's going to have points like here and up 1 and over 1, and you'll notice it was a steeper line that I'm drawing here. So we had that line y equals x, 1x. So that's what this r is very similar to. It's the slope of this correlation. You know, the higher that number gets, the steeper it gets. The closer it gets to 0, the shallower it gets. So when I say higher, I should say the further away from 0. So I would imagine if I had a correlation of something like 23x, that when I look at that graph, it is going to be really skyrocketing, kind of going straight up. So that's what we're taking a look at with that correlation. And in the next video, we'll talk about doing some of the calculations in order to figure that out.